Hi everyone, I'm Mushtaq Raza. Due to some reason I didn't join the conference. I will try my best to make my paper easy for you in this video presentation. So let's start the presentation. I'm a PhD student in the Department of Informatics Engineering, Faculty of Engineering, University of Porto. I'm doing my PhD in software engineering and working as a researcher in the Technology and Science Associate Laboratory, Portugal. This work is about empirical evaluation of the ProcessPAIR. ProcessPAIR is a novel tool designed to help developers analyze their performance data with less effort, by automatically identifying and ranking performance problems and potential root causes. The growing adoption of software development processes such as team software process and company personal software process, and the cloud-based tools that generate a big amount of process performance data that can be periodically analyzed to identify performance problems, determine their root causes, and devise improvement actions. Although several tools exist to automate data collection and produce performance charts and reports for manual analysis of PSP-TSP data, but practically speaking, there is no tool support exists, at least for PSP-TSP, for automating the performance analysis. A manual analysis of the performance data for determining root causes of the performance problem and devising improvement action is challenging because of the potentially large amount of data to analyze and effort and expertise required. Here is our overall approach to automate the performance analysis. Our approach basically draws inspiration from existing work on process performance model, benchmark-based approaches for software product evaluation, and the defect causal analysis techniques. Basically, our approach involves three main steps: define, calibrate, and analyze. Process experts define the structure of performance models suited for process under consideration, for example, PSP, TSP, or some other processes. In our approach, a performance model comprises a set of performance indicators organized hierarchically by the cause-effect relationship. The second step in our performance model is calibration. The performance model is automatically calibrated based on the performance data of many process users, the statistical distribution of each performance indicator, and the statistical relationships between these performance indicators are computed from dataset, which I will explain later in this presentation. Once the performance model is defined and calibrated, the performance data of individual developers can be automatically analyzed by our tool ProcessPAIR to identify and rank the performance problem and root causes. The link for our tool is given on the left corner of this slide. You guys can download the tool and can experiment with the example PSP data. Here we will explain why we instantiate our model for PSP. This is because PSP is a well-defined process having measurement framework for performance analysis and improvements. There exists large dataset available from the Software Engineering Institute. PSP class data of around about 31,000 data points. There is project submissions are used for this PSP model calibration. Also, defining this for PSP will help PSP developers in producing their performance analysis report. To best fit the specific context of PSP training and technological demonstration, we used PSP performance model defined in our previous work with some minor changes. We configured the modified performance model as a tool extension. The full set of top-level and nested performance indicators can be viewed in the first column of the table. We considered three top-level performance indicators regarding predictability, quality, and productivity. A major predictability performance indicator in PSP is the time estimation accuracy. which we measure by the ratio between actual and estimated time, being 1 the optimal value. Since in the PSP probe estimation method, a time estimate is obtained based on size and productivity estimate. That is why we consider in the model that a time estimation accuracy is affected by size and productivity estimation accuracies. Product quality is usually measured by post-delivery defect density. However, since the scope of the PSP is to develop small programs as the components of a large program, post-delivery defects are seldom known. So the PSP process aggregate the quality measure, the process quality index, that constitute an effective predictor of the post-delivery defect density. You can see in the table factors that affect the product quality index. You can also see the exact formula in our previous work. Regarding productivity, in the PSP, productivity is usually measured in a line of code per hour, in spite of its known limitations. Since in the PSP, time is recorded per process phase, when a productivity problem is encountered, one can analyze the productivity per phase in order to determine the problematic phases. That's why you can see productivity phases in the first column of the table, which together affect the overall productivity. You can also see the exact formula in our previous work. Here in the experimental assessment, first we will talk about data under analysis, then the research question we propose, and finally the results of performance problem and their root causes identification. We will also show an example of the root causes identification. The subject data under analysis is based on datasets from Tecnológico de Monterrey in Mexico, referring to 10 subjects that developed 6 projects, each using the PSP, in the scope of Software Quality and Testing course in 2015. The subject used Process Dashboard for collecting the standard PSP-based measures during their projects. In the end of the sequence of projects, the subject analyzed their personal performance along these projects and documented their findings and improvement proposals in a performance report. The performance report was initially written in Spanish language. The overall objective of this study is to assess whether ProcessPAIR tool is able to accurately identify performance problems of individual developers and their potential causes in the context of PSP training, so that subsequent manual analysis for identification of deeper causes and remedial actions can be properly focused, and effort can be saved. More specifically, the goal of this study is to answer the following research questions regarding problem identification. Is it possible to automatically analyze performance data of individual PSP developer in order to identify performance problems with similar results but with less effort than in manual analysis? Regarding root cause identification, is it possible to automatically analyze the performance data of an individual PSP developer in order to determine the root causes of identified performance problems with similar results but with less effort than in manual analysis? Following research question 1, which is about problem identification, among the 186 cases analyzed, there are 180, that is 96% matches, with only 3% false positive and 1% false negative. The false positive and false negative correspond to boundary situation. You can see in the table. Following research question 2, that is regarding the root causes of the performance problem identified in both manual and automatic analysis. In 19% cases, the tool and developer pointed out the same causes. Here the tool benefit is the elimination of manual effort. In 54% cases, the tool pointed out intermediate causes and the developer pointed out deeper causes. Here the tool benefit is the reduction of manual effort. In round about 27.5% cases, inconsistent results were found because of the faults, errors in manual analysis. Here the tool benefit is the prevention of user error. From the previous slide, it is clear that tool has benefit over manual analysis. In this example, you can see the comparison of the results about problem and root causes identification that is extracted from the performance analysis report in manual analysis and from the tool in automatic analysis. In the comparison section, you can see how the manual and automatic analysis are considered to be matched, deeper manual analysis, and fault in manual analysis. The results of the study show that ProcessPAIR tool is able to accurately identify performance problems of individual PSP developers and potential causes of those problems. Hence, the subsequent manual analysis of identification of deeper causes and remedial action can be properly focused, reducing the overall effort and possible error in manual performance analysis. As a future work, we plan to build a comprehensive catalog of improvement actions to recommend for the highest ranked causes, build similar model for analyzing performance data produced in the context of other processes, and conduct further experiments for assessing the effort gained with our tool. Thank you for watching this presentation. If you have any question regarding this presentation, you guys can write me or my supervisor on the following email addresses. Thank you.